We are live now.
Okay.
Okay, just a moment. Dr. Shipra, means I can communicate with the students or?
No, sir, you will be YouTube
Okay.
live and
Okay, that will be live, right?
Yes, the way we do generally. If there are any questions or anything, I'll be there to communicate with.
That's okay. So,
with your permission, shall I begin? Shall we begin, sir?
Yes.
Okay. So, good morning, everyone. Good morning, students, colleagues, and friends. And welcome to this live session of our Executive Development Program and Certificate course on data analysis using SPSS, which has been organized under the Teaching Learning Center, Ramanujan College, under the Aegis of Ministry of Education scheme, funded Madan Mohan Malaviya National Mission on Teachers and Teaching. As you all are aware, you have been doing the sessions on SPSS. And our expert, Professor Masood Siddiqui, is here with us, and he has very well, very graciously accepted to be live with us and do a session on graphical visualization. So we all know Professor Siddiqui, so he doesn't require any introduction as of now. So I would directly, without wasting any time, request Professor Sir to kindly take over and begin with this session today.
Okay. Thank you, Ms. Shipra. And good morning to all. So we will be starting the session, and here I will be using two cases so to present the different aspects related to graphical representation, and I will be sharing a slide also, and I will be writing on that, and all this material would be available to you, so don't worry about that. And I will try to be as simple as possible so that everyone should be on board. And when if you people have some problem, you can always inform the organizers. Then I will be hearing that. And there's a request to Ms. Shipra that I am sharing my dual screen. So sometimes there may be some compatibility issue if there is. So kindly do indicate.
Sure, sir, sure.
Okay. And kindly allow me screen sharing.
Yes, just a second. Ravi, sir, just give me a second, sir. So, can you see now?
Yes, it is there. Okay. So, so today we are starting with the graphical visualization. And here I have shared my email ID as well as number also. So if you people face any problem, you can always discuss. So here, there are two words that define the topic, right? The first one is related to visualization, right? Means we are using some visuals so to represent the data. And these visuals are in the form of graphs and diagrams. So these are the things that we are going to discuss. First, we discuss what is the objective, why we are doing this. After that, I will be moving to some case, right? And I will be establishing that. So suppose we start with the initial part, right? There is a research question or there is a question in front of you, and you answer that question in an objective manner. Since you answer that question in an objective manner, if you require an objective answer, you require some information. Okay? And if we go with the data-based information or the numerical information. This numerical information is known as data. So as we define, our data is a numerical information, right? Uh, with the different analytical tools and with the data science and the analytics reaching up to at every level of our life as well as our academics, right? Everything can be converted into the numbers, and these numbers should provide us some information. So our objective is to derive that information, and through that information we like to have, or we are committed to have, some meaning from this data, right? So this is the objective for which we are starting with. Now our data can be in the form of structured data or in the form of unstructured data, that will be in any form. When we say about the structured data, either we talk about the Excel, or we talk about the CSV file, or we talk about the SPSS, or even in the analytics when we talk about the data frame, right? So whatever the uh, tool or the technology is there, there is a well-defined format. Normally, our format is in the form of this grid, which is in the form of some rows and some columns. Conventionally, the cases or the sample, right, or the units are uh, on the rows. So there can be 1, 2, 3, and so on. And on uh, the vertical part, that is the y-axis, we may have variables or the features, means on which information is being collected. So that is V1, V2, and so on. So this type of data is actually known as structured data. And this structured data is used for all the future lectures that we are going to take up, right? So we put the data in some structured form. So even if we collect the data in the form of unstructured form, means no form, we can always convert them into the structured form. Now, we have three types of data. One is the cross-sectional data, that is a one-time data. All the surveys that we do belongs to this type of data, that is a cross-sectional data. The best example is we have collected the performance of student for 1 year, or we have collected the position of shares or the returns of all shares on Friday last. That is known as cross-sectional data, right? Means the cross-sectional data would be primarily in the form of x-axis. And the another one is a time series or the longitudinal data, where we arrange our information as per some time element. For example, we can have year, and here we can have the production of some, like production of microchips, right? So here we arrange the data, or we can have year, here we can have the population of any particular portion, right? So here we arrange the data as per the some time element. So this is known as time series or the longitudinal data. When we mix these two, this is known as panel data. Like we can have the performance of the students of some particular college for the last 10 years. So on x-axis, we have the complete performance covering the different subjects, CGP, etc. And on the y-axis, or right, we can have the time element also. So this is the data. Now we have two types of data. The first one is the metric data, which means the measurable, right? So everything would be in the form of numbers, but that numbers can be used for some metric purpose or for some categorical purpose or non-metric purpose. So we have both type of variable. One is metric and another is non-metric. For example, we can have the height of the student. So the height can be in the form of 155 centimeter, 167 centimeter, and so on. So this is measurable. This is a metric data. And another thing is we can use gender, where we can have females and males, right? So this is categorical data. Or even if we can have all the students which are above 160 centimeter and which are below 160 centimeter, right? So which are above 160 centimeter, they are being put a code 1 and another are put code 0, right? So this is again a categorical data. So that type of data is known as non-metric data. Why we are going to discuss this? Because these are the information that is used for all future analysis purpose. Means the tools that we decide are actually based upon whether the data is quantitative in nature or data is metric in nature or data is non-metric in nature. So that's why we are doing this. Then on the basis of this, since measurement and non-measurement is important, so we have 4 primary measurement scales, right? Which covers all type of data, means all type of numerical information. Remember, everything is in the form of number. So number doesn't mean that everything is same, right? So that's why we are going to discuss different number of scales which are based upon certain rules. So the first one is known as nominal data or the categorical data, where where the objective of such a scale is just the naming purpose or just the nomenclature purpose. This is example of the gender or this height bifurcation comes under the nominal data. In the same way, the shirt number of the players or the uh, room number or your roll number all comes under nominal data or the categorical data. Since here it is used only for the numbers, so only one mathematical operation is possible, that is known as counting, right? So let me have another slide so that I will be explaining them in a bit detail. Okay. So first here we are discussing the nominal scale. So as we have discussed, here the number are used only for the naming purpose. I have already mentioned the example. Since um, here the numbers are used in the form, right? Numbers can be also used for the naming as well as for the categorization purpose. So here only one mathematical operation is possible, that is the counting. So only one mathematical or statistical operation is possible, that is counting or frequency. Since only one mathematical operation is possible, that is we can only count or we can have frequency count, right? So the measure of center tendency or measure of average that can be used is the mode, right? So if data is in the form of nominal scale, we will be using mode. And if we go for the dispersion, means what is the level of variability present, then there is no measure of dispersion, right? And there are other tools that I will be explaining when we are going for some other lectures, like what are the tools that are used for the relationship purpose, what are the tools that are used for the testing purpose. Anyway, this is the basic introduction of this data. And this is the first uh, on the stage. So this is the simplest, but it provides least information. So as we go forward, we have somewhat complex or providing more information also. So the another one is known as ordinal scale, right? This is the rank order scale of, this is the rank order scale. And we also say it is of lowest order. So why we say lowest order? Means all the scales that we are mentioning after the ordinal scale, they are also the rank scale, but they provide us some other information also. So this is the most basic rank ordering scale in the form of ranking. Now, it contains two properties. Name will always be there. And there is one more thing that is known as order. Like there is no ordering in the nominal scale. Suppose you have put female as 1, male equals to 2. These are the codes on the nominal scale. So it doesn't mean that 1 is more than 2 or 2 is more than 1. But here we have order also. Like we provide ranks to the students, right? So the rank 1 would be at the highest and rank 2 would be at the lower position as compared to 1. So here the values that we put 1, 2, 3 are in the form of order also. Okay. Right. So since it contains order also, so along with the count and frequency, right, it also have some property that is in the form of centiles, right? That is in the form of arrangement and finding a particular value. So it is based upon arranging the data as per the order. Right? So accordingly, the measure of central tendency that can be employed here is known as median. And measure of dispersion or the measure of variability that we can use is interquartile range. Okay, these are the order. And there are other tools that we are not discussing that are related to relationship and the testing purpose. So this is the ordinal scale. Now, these two scales that we have discussed so far belongs to the category of non-metric. Means they are not measuring anything. So these two scales are primarily non-metric scale that I have introduced earlier. So after that, we will be going for another scale that is known as interval scale. Right. As we discuss rank, suppose the first student have secured 90% mark, the second student have secured 89% mark, and the third student have secured 80% marks. They are in the merit list. So the rank would be 1, 2, and 3. So as you can check, the difference between 1 and 2 is just 1 unit, but the difference between 2 and 3 are the 9 units, 9%, right? So here, difference doesn't have any meaning. So when we go for the interval scale, it has the characteristics like naming. It also has the characteristic of order, right? Because here, um, 2 would be either greater than 1 or 1 would be greater than. And after that, we have a concept of difference also. Means equal difference on the scale is equal to equal difference on the magnitude. So these scales are primarily used by people from social sciences, etc. Right? Uh, if we go with the Likert scale, right, or the even the students of the management also uses this. Right? So if we define the 5-point Likert scale or 7-point Likert scale, so it primarily comes under interval scale. Right? Suppose we have asked a question: are you agreeing that um, the environmental condition is good, right? So we can have the response in the form of highly disagree, then we have can have disagree, then we have neutral, then we have agree, then we have highly agree. And here we can put the scale as 1, 2, 3, 4, right? So here naming is there, 1 represent HDA, 4 represent agree, ordering is there, 2 is greater than 1, 5 is greater than 4, and so on. And there is a constant difference also. The difference is also there. So this is the first scale that comes under the category of metric scale. Here we are measuring something. Okay. Since it comes under the metric scale, right? So it it measures also, since it measures also means it consider the value. So the measure of central tendency that can be used here is mean, and measure of this because it is based upon the measurement. And if we go for the dispersion, here we can use standard deviation or the range, right? So these are the interval scale, right? Now we come to the last scale that is known as ratio scale. So this is the highest order scale, right? Having all the characteristics. So what are the all the characteristics? Previously, we have 3 characteristics, that is name. The next one is order. Next one is difference, right? And it has one more characteristics, that is the characteristics of the ratio. Ratio means 2, in this case, 2 is twice of 1, 4 is twice of 2, and 4 is twice of 4. 4 is 4 times of 1. So why it has a ratio characteristics and why it doesn't have ratio characteristics? Because in the interval scale, origin is local. Means there would be an origin, but there won't be that absolute origin. Means we can start this scale by 1, we can start this scale by 0, we can also start this scale by -2, and so on, right? So that's why it does not have the ratio property. But this ratio scale also have origin, but it has a global origin. Means everywhere the origin would be 0. And the example is the real measurement, like the measurement of the height, measurement of the weight, and so on, right? So these are the 4 scales that we use, right? And this is also comes under metric scale, right? So why I have introduced this? Because these are used for all the future decision, so that we have a better decision related to the tools. So these are the skills that we have discussed. Data analysis we are not discussing at present. We will be discussing later on. So now, what I am going to take up in this session comes under exploratory data analysis, or EDA. Right? So this is the first introduction of the data with the researcher or the analyst, right? So this is the first introduction of data. So this is the first, since this is the first introduction, right? So what it is being done, that this data is being screened. So that is known as performing environmental reading. It can be done by for two purposes. What are the two objectives? The two objectives is we want to describe the situation. We want to describe the data. So for that, we use descriptive statistics tool. And the related thing is, since the data that we receive may be of good quality or may not be of good quality. So it is actually related to quality check of the data. So if data is of good quality, we go with that. If data is not of that good quality, we will be improving the data quality. Otherwise, garbage in is garbage out. So since we have mentioned these two, so again, I am repeating that. So the objective of the descriptive statistics is to describe or to summarize the data so that we develop a basic understanding about the data. Okay. And the next objective is the data examination that I have mentioned. That is examining data before applying statistical data. So again, I am reiterating this, that the objective of this, since this is the first introduction of data, is to gain insight through the data screening. We will develop a basic understanding of the data and the relationships that are possible. So they are in the form of suggestions only. And these suggestions are confirmed as we go for some confirmatory analysis that would be covered in the future lecture, right? And the second purpose is that ensuring that data underlying the analysis meet all the requirements. So all these requirements are as per the requirement of the tool, as per the statistical tool. So this is also known as investment in the data analysis technique. Why the word investment? Right? Since the time you invest would finally be resulted into a better analysis or better understanding of the data. Otherwise, I have always mentioned that garbage in is garbage out. So now we are coming to this part that is related to data visualization. Right? So for data visualization, we examine the data through the graph. So remember, our objective is not just to create the graph. Our objective is to draw meaning from the data. Right? So since our objective is to draw meaning from the data, and for different persons, meaning would be different. So you will never be mentioned that which graph is to be put, which graph is to be drawn. we will decide is as per our purpose, as per our objective, and as per the data nature, we decide which type of graph we will be using. So it can be only for the univariate profiling. Univariate profiling means we consider variables separately like V1, V2, and so on. So through this, we examine the shape so that we have a better understanding about the data. And another one is the bivariate profiling, where we have two variables, X and Y. Since we are having two variables, right? So there two variables simultaneously we are considering. So there should be some objective. One objective is we can examine the difference, whether they are difference with respect to central tendency or whether there is difference with respect to variability and so on. So at the first stage, we examine what is the group difference. The second thing is we examine whether there is some potential relationship between the variables. If we observe some potential relationship between these variables, this relationship is being confirmed as we move forward. So this is the graphical visualization part. Now I am coming to these two parts, like the first part that is the descriptive statistics. We use the different tools like center tendency, which covers the different measures of center tendency that I have mentioned also. Then we have different measures related to dispersion. These are the different measures that shows the uh, variability that is present in the data. So actually, these two are the most important summary statistics measure. Why they are important? Because whenever we have a data, this data has two inherent property. These data to have omnipresent property. The first one is data must be similar in some aspect. Why data must be some similar in aspect? Because data is being collected for some objective, for some purpose. So there must be some similarity in the data. And this similarity in the data is being examined or is being measured by these measures of central tendency, right? Which shows us what is the overall, what is the general tendency, what is the central tendency of the data. So now, as I have mentioned, that the data have one inherent characteristics that is similarity. It has another characteristics also that is known as dissimilarity. So this dissimilarity is being examined by the various tools that are there in the dispersal, like standard deviation, interquartile range, and etc. And these two other tools which are used actually for the visualization purpose. This I will be showing you. They decide the shape of the distribution. This first tool, skewness, is primarily related to whether the data is symmetric in nature or not. Symmetric means whether the top comes in the middle or there is some skewness in the data. Okay, right? So this is a skewness. The second one is a kurtosis that examine or that discusses flatness or peakness of the data. This data would be in this form, right? This is much flat or this is normal, and the another representation would be this way, right? So here data is having less flatness and higher peakness. So this is for the shape of the distribution. Now these are the different graphs and diagrams that we are going to discuss, right? Here I am not taking that name. Why I am not taking that name? Because as we introduce the graph, right, then that would be very clear that why bar diagram is being plotted and why scatter plot is being plotted, right? So now I am going to our data set, right? And through that, we will be first constructing the graphs, and after that we are editing, and simultaneously we will be discuss what those measures gives, what those diagram gives us, right? So this is the introduction part. I will be sharing this slide, so don't worry about that. Now I am changing the screen. So hopefully this SPSS sheet is there.
Yes, sir.
Okay, right. So hopefully we won't have any question or the questions would be later on.
So till now, we don't have a lot of questions.
Okay, right. Now here, the case that I'm going to use, this is the open-end case available without any cost, so that I will be sharing you. This is the case with the title or the file name is grades dot. This is the grade data. Okay, right. Uh, Means some information related to grades has been collected, right? And these are the features or these are the variables that are there. Like the initial part is related to name or the introduction of the student. Then we have gender, right? This is the nominal data, whether the student is female or male. There are two categories, right? Ethnicity means whether the student belongs to which part. Then we have whether the student is a fresher or belongs to the different class. Then we have lower or upper sections, right? Then we have section. This is a GPA, grade point average. This is did extract, credit, review, attended review, and these are the 5 quizzes that are taken. Then we have next variable as final. Then we have total. Then we have percentage, right? This is the grade, whether the student is pass or fail, right? So we have mixed type of data where we have the different scale. So now here I will be introducing different graphs through that, and this is the data set that is there. So the first graph that I am going to draw is the bar diagram. Right? The first graph that I am going to draw is the bar diagram. Right? Just a moment. So, so the bar diagram primarily means, just a moment, means we have something on the x-axis and those measuring that would be on the y-axis, right? So here we will have different bars that represents the different values or the numbers, right? Like here we will be having total on the y-axis, and on the x-axis we have the sections, right? So this is the simple bar diagram. Suppose we want to draw this bar diagram. Now I am discussing the clustered bar diagram. This is the simple bar diagram that represents what are the totals, what are the scores of different sections. And now along with this, I want to introduce the gender also, like what is the position of male and female, right? So we require two bars, one represents female and another represents male. Okay. Right. So we will be attempting this diagram. So here some section is on the x-axis, total is on the y-axis, and we have a further bifurcation with respect to gender. So this is the diagram that we are going to attempt here. Right. So here I am drawing that diagram. And initially I am introducing, so for the diagram, we will go with this tab that is the graph, right? And here I am introducing the option that is a chart builder. It is available in all the software, and here we are using the SPSS. So we will be building the chart. We are not directly uh, having the charts, right? Having the diagram. I will be showing you the other way also. Anyway, now we are building the charts. Right? So, so as we click the chart builder, this dialog box would be open. Here in the gallery, you have the different diagrams. Like here, we will be having the first diagram, that is the bar diagram. Now it asks us which type of diagram you want to draw. If we have a single information that is in the form of section in the total, then we can go with this simple bar diagram. But here we are requiring the diagram for section versus total, as well as we require in the form of male and female. Means we want to break, we want to bifurcate our total with respect to male and female. So So here we are clustering the bars, right? So that's why I am selecting this. The another way is the stacked bar also, right? Means one bar on the another, but it is not that much preferred because here, what is the problem? Like in the initial one, everything starts with the base 0. But here, everything doesn't start with the base 0, right? So it will be a bit difficult to be interpreted. After that, these diagrams are actually related to more than, means related to two-dimensional case. So that I am not discussing. You can always practice, right? So we select this and we transfer this. So as we have selected the cluster bar diagram, so it has provided us x-axis, y-axis, as well as cluster also, because we have selected it. If we select the first one, then the clusters won't be there. So since here we will be having total on the y-axis, just a moment, right? We will be having the total on the y-axis, right? And the categorical variable, that is a section on the x-axis, right? We simply select that and drag that. And we want this diagram with respect to gender. So we take up the gender, right? And drag it and drop on this cluster case, right? So here, all the three variables are there. This is section, that is nominal, right? This mean total is metric in nature, and gender is again a non-metric data, right? So if we put OK, so this is our diagram, right? So these are the scores obtained in the different sections, okay, right? These are the scores of these boys and girls, right? Now, we are going for the editing purpose, right? So for editing purpose, we have to make the graph active. So how that can be made active? We will be double clicking them, right? So we have, just a moment, right? We have double clicked them. So since we have double clicked them, so this diagram become active, right? Now we will be, now I will be introducing some basic editing steps that we are going to discuss. Now, as you see here, up to a particular point of time, there is no difference, right? If we go with the mean total, like 80, there is no difference in the diagram. So there is no point of having these bars from 0 to 80, right? Instead, we should highlight the difference which is there only, right? So 0 to 80 is not much of the use, right? So what we are going to do, we are changing the scale. And obviously, we are changing the scale on the y-axis only because y-axis is having some metric information or the numerical data. So how that can be done? Here we go to the y-axis value and we double click. So as we double click, then I am going again, right? We go to the y-axis values and double click. So once we double click, we will be having this sub dialog box. And in this sub dialog box, you see there is a scale, right? Here you can use other thing also, like you can change the text color, you can change the number format, right? So you can change the label also. So that I am not discussing here. I am discussing how the scales can be changed, right? So as you see here, we start with the 0, right? Suppose we don't want to start at 0. As per our observation, there is no value up to 80 or 85. So we are starting with minimum as 80, maximum would be 120 as being there also. And the major increment means, as you have seen earlier, the scale categories are, the scale classification are 0 to 20, 20 to 40, 40 to 60, and so on. So the major increment is 20. So now instead of that, since we are deleting values up to 80, so and we should highlight the differences. So we make major increment as 10. Then we change the origin also, since we are starting the graph from 80 only. So we have the origin at 80. Okay. So these are the things that we do. Fine. Okay, just a moment. Just a moment. right? So here I am making the change. So this is 80. Okay. Then we put the major increment as 10 and the origin as 80. Okay. And then we apply. So all these changes are there, right? And you can check also that you can see that this is the thing, right? Sorry. If we close this, so this is now the scale has been starting from 80 only, right? And these differences are highlighted up to a better level. So this is the editing the scale or the increment value. Now, suppose we require the grid values from both the side, x-axis as well as on the y-axis. So again, we make the diagram active, right? And click on the y values, right? So after that, you can select this. This is a tab which is showing hide grid line because there are grid line horizontally. So we hide and then we again take. If we again take, so options are there related to grid lines. So here we will be selecting both major and minor ticks, right? We will be having grid lines horizontally as well as vertically, right? This is the case when you require that. If you don't require that, if you think that's okay, so we are not going with that, right? So as you can see, these are the changes, right? We have introduced the grid lines, okay? So this is the second editing that we are. Now the question arises. Suppose we go for the section 1 and you want the mean score for the female, this value, right? So now you are not very sure that what exact this value is. You can guess that it can be, it would be around 103 or 104, right? But it is not, but it is not written there. So sometimes you may have the exact value. So we are now adding the labels inside these bars so that we have those values. So what we can do, we can again make active, right? Then we we click here, and this would be highlighted. This tab is show data level, and if we click at show data level at present, what we want to display. Here, already the mean has been displayed, right? So suppose we require these values automatically. So all the values would be in the middle, as you see 104 and 107. Suppose you require this on the top, right? So you can change the custom and you can put that on the top. Otherwise, the in the middle, that is the default part is also here. And suppose you require the percentage also. So along with the total, you require the percentage also, right? So you drag the percentage to the displayed part, right? We have selected the percentage and transferred it to the displayed part. And if we apply, right? So we close. Now we have these values. So as you can see here, right? We will be having numbers as well as the percentage also. These are the mean totals also. Okay, right? This is related to male and female. So this is the putting the information on this. So this is the bar diagram. This is the basic diagram that I have introduced. We have uh, here we can have numbers, actually the numbers on the y-axis. So for some other data, we can plot this diagram. I will be showing you when I am using the another case also. So that can be used on totally for the categorical data also, right? But here, just to make you familiarize with the construction of the diagram. So this is the first thing that we have attempted. After that, now I am attempting another diagram that is known as line chart. So first, I am introducing the concept also. What does this mean? So the first one is the bar diagram that we have discussed. This is a line graph or the line chart, right? As the name suggests, in the first part, we draw bars. Here we will be drawing lines also, right? So, so here also we will be using the same situation. But instead of this, we are drawing the lines. So there will be section on the x-axis and their mean scores are on the y-axis, right? And we will be drawing, right, the lines. And if we use the clustered line, so one would be for males or one would be for females. Okay, right? So this is known as the line chart, where we represent the values through a line, right? Instead of the bar, we are representing them through the lines. Okay, so here I'm mentioning how that can be constructed. So for that, we again go to graph, then we go to chart builder, right? Then we go to the line, right? As we go to the line, right? Here we have the two diagrams. This is a simple line and this is a multiple line. Since we want to present the multiple data, right? Because we want the clustered line chart also with respect to male and female. So that's why here we are selecting the second one. That is a multiple line. Select, drag and drag that to the preview window. So here we have selected this and transferred it to the preview window. Then we have total on the y-axis, sections on the x-axis. Okay. And then simultaneously, we will be using grade also so that everything would be there in one go. Okay. Right. So we have two lines. One would be for males and one would be for females. And if we put OK, right. So this is the multiple line count of section by gender. You can always change the heading, right, by highlighting that. And after that, you can change the headings. Okay. Right. So now these are the lines. So this blue one is of female. Females are scoring higher amount, and this red is having for the red, right? So this is the line diagram, right? So after that, we are again editing. Like here, just a moment. So I should draw on the previous, right? So on the previous information, so that would be better to compare. So that's why I am repeating this again. We go to graph, right, chart builder, and on the y-axis, instead of the count, we will be having the total. Okay, right? So that would be better for the comparison purpose, right? So these are the total, right? Here the blue one is the for female and for the males, right? As you see, their mean totals are different with respect to different sections, right? Like section C is where the girls are better performers, and for uh, section one, the boys are better performing slightly. Okay. So as you see here, again, I'm repeating that since there is no value up to 80, there is no point of having this value, right? So I'm just repeating, we are starting our origin from 80 on. So we are going to scale, right, and changing. This is just for the repetition purpose so that you people got familiar with this. We are introducing minimum from 80 so that the irrelevant part that is from 0 to 80 is being deleted, and the relevant part that is from 80 to 120 would be highlighted in a better manner. So that why we are having a major increment as 10, and then we have origin also at 80. Right? Okay. So now you can see the values are from 80, and if you close that, you will be getting the new diagram that is being started from 80. Suppose we require the grid lines also. So here we have hidden, and again if we click, it will show both major and minor axis. So if we apply, now we have the grid line. Is that okay? Right. So means the scores are now better highlighted because everything has been converted to a total of to a origin of 80. Now, since here they are in the form of colors, only red and blue. So at present they are visible. Suppose they have you have taken out the printout of this line, and that printout is in the black and white. So we cannot differentiate which one is for female and which one is for the male. So here I am introducing a new concept that can be used otherwise also for the different diagram. We are adding markers to these limits, right? So how that can be done? We will be highlighting the graph, and then here, this is the add marker. If we click this, so as we click this, so this markers has been added. This blue circle is for the female, and this red circle are for the male. And here on the diagram also you see this markers has been added. Now we are introducing the different things. So how that can be done? We go to this marker and double click. Right? Again, I am repeating that. We go to the marker for the female, right? And double click. So here, this is a sub dialog box that is being opened. Now we click on the marker, right? This is a marker tab. Now, the first thing is the type. We can change the type. Suppose the type we are putting this. And at present, there is no color that is being filled in the marker. So here I am filling this color that is dark. Okay. So dark blue is being done and we apply. So as you see here, these markers become blue and in the form of that inverted circle. Now we are repeating this for males, right? The type would be something different. And here, this is the type, the uh, upper sided triangular, right? And if we go with the fill and we are filling with this dark, okay? So here, as you see, the markers are being created. You can change another marker also so that the difference would be highlighted in a better manner, right? So this is the introduction of another editing that we do with the line diagram, right? So these are the two. They are much similar, just the appearance is different. But this line diagram can be used for other purposes also that I will be introducing with the lectures. Now, after that, I am going to discuss another diagram that is known as pie chart. So this is the whiteboard. Now we are going to discuss another diagram that is pie chart. So the concept of the pie chart is the total is being represented as area, as angle that is being made on the circle center by the section or the whole radius. So as this is a circle, so the angle made is by the whole circle is 360 degrees. So now since total represents 360, right? Suppose a particular value, suppose that value x is having an amount of x only. So what is the corresponding angle? So it would be 360 divided by n into x. Okay, right? So this is the concept of the pie chart. Means we divide the total as per the shape of the different pies, okay, which are actually determined by the area taken by that number, right? And this area is proportion to the proportion in which this circle is being divided, or the angle on the center is being divided. So this is the concept of the pie chart, a known figure. Now I'm going to discuss how the pie chart is being constructed. Okay. So for that, I'm just repeating the same thing. We are going to graph, then we are going to chart builder. We are resetting, and here I am taking pie or polar. And there is only one type of pie. So I will select that and transfer this to the chart preview window. Okay. Now here, right, uh, uh, I'm introducing the last two data that I have used is not being done here because we don't have any two variables. Okay. So instead of this, I am taking something else, like I am taking the grades. What is the position of the grade? That is a nominal data. So this is all in all a nominal data, right? So here I am um, taking the grade, and this grade is being drawn here, right? So this is the grade that here I am using. We can use filter also. Anyway, we just have selected the grades, and we are dividing our circle as per the different grades like A, B, C, D, and so on. So this is the grade, and if we put OK, so this is a slice by. So this is the position of the different grades like A, B, C, D, F. As you see, the maximum number is of B, this rate, and actually the maximum number of the grades that are there is C, right? And after that we have B, right? And A's, and after that we have A. So this is the division of the different grade. This is A, this is B, this is C, this is D, this is F, right? The student is failed. So this is known as pie chart, okay? Right? This is the example of the pie chart. Now we are again editing this, right? We are editing this. So what is the first addition? Suppose we want the percentage and frequencies on this graph, right? So what can be done? Sorry, right? We click on this, just a moment. Okay? And after that, here, the symbol is show data label. So we click the show data label. Okay. And here, along with the percentage, we are having counts also. This I have done earlier also. So along with the percentage, we have count also. Or you can have only percentage. Anyway, we are having both, and we apply. So as you see here, number of A's are by 23 students, which is in the form of percentage 21.90, right? Actually, here we require the percentage more as compared to the count. And the number of B's is by 32 students, and the percentage is 30.48. And number of C's is by 35 students, and the percentage is 33.33. So this is the division, right? You can do one more thing, like here, right? So this you did, right? This, just a moment. So this are being done, right? Suppose if you want the further further change, you can change the number format also. Like here, decimal places are not being mentioned. If you mention 2, right, the numbers would be 2 after the decimal place. Otherwise, you can have decimal place up to 1 also, right? So you can use this option also. As we have mentioned the decimal as up to the 2 place, so even the totals, that is 6, 9, 35, 23, and 32, also being converted into the 2 place. Okay. So this is the having the labels on these slices, on these files, so that they represent more meaning. Right? After that, if you want to change the color, suppose you want to change this color. So we click on this blue part, right? And we click that. So on the double clicking, I'm just repeating that again, right? We can do, right? Since this is the color at present, it's being used. Suppose you want to change the color. So you go to this legend and double click this. So at present, the color is the light. Suppose you require the dark blue color. So you can have this dark blue color also, right? And furthermore, suppose you want to explode this pie, right? You want this pie to be separated from the pie chart so that this would be uh, more apparent to the observer. So here you can click this explode part, explode slice, right? So this part goes out. In the same way, if you want to repeat this for anything else, right, you can do that again, right? As here it has been mentioned that this portion is being exploded. So this is the pie chart that we have discussed. After that, I am introducing a very important chart which is being used for multiple purposes for examining normality as well as examining outliers also. That diagram is known as box plot. So now I'm discussing the another chart or the diagram, very important one, that is known as box plot. Just a moment. Okay. So here, yes, just a moment. I should have my, yes. Now here, I'm introducing the another diagram, and the diagram name is box plot. Okay, right. So first, I am discussing what the box plot, how the box plot looks like. So it is somewhat like that. It is in the form of two boxes and two whiskers, right? So these two are the whiskers and these two are the boxes, right? This central line through the box represents median, right? Means 50% observations are below it and 50% observations are above it. This part, this line represents Q1. Q1 is the lower quartile. Lower quartile means 25% observations are below it and 75% observations are above it. Right? So now this line represents the position of third quartile Q3. This is also known as upper quartile. Upper quartile means 75% of the observations are below it and 25% of the observations above it. Right? Then I'm introducing one more concept that is known as interquartile range. This is the difference between Q3 minus Q1. Right? This is right. And after that, this whiskers covers a distance of one interquartile only. Right. So all the observation that comes under here covers at the distance of one interquartile. Means this is the position of Q3 minus 1 IQR. Sorry, Q3 plus 1.5 IQR because we are going upward. So this is Q3 into 1 IQR, or we should write 1.0 so that would be more clear to you people. This is 1.5 into IQR. In the same way, this is also 1 IQR. Right? So this is the position of Q1 minus, Q1 minus 1.0 into IQR. Okay, right. Now anything that lies beyond that, anything that lies beyond that, either up to 1.5 IQR or beyond that, right? They are being termed as outliers. And after that, if they lie, that is the extreme value. Here, I am not going into the detail, means what is the difference. And here also, all the values that are beyond these values, beyond this whisker, comes in the category of outliers. Or extreme values. Okay, so this is the position. So here outliers or extreme values are also being shown. Conventionally, outliers are being denoted by star. Sorry, outliers are being denoted by circle. Just a moment. Mhm. Outliers are being denoted by a circle, a small circle, and extreme values are being denoted by star. Right? Here I am not going into the detail what is the statistical difference between these two outliers or extreme value. But remember, they are the separate things. But broadly, in a number of times, we use them in the form of synonymous only. Right? So this is the position of outlier. So one, it gives whether the outliers are there in our data or not. The second thing is it can also be used for the normality examination that we may discuss later on. Whether the data is normal or not, that can be done by the box plot. Right? Along with this, it can be used. So what are the objectives of the box plot? Very important diagram. One objective is examining normality or otherwise. Right? Another objective is finding outliers or extreme values. Okay. After that, the next objective that we can have, it can be used for comparing the center tendency. This I will be showing you also. Comparing the central tendency of two or more distribution. Means whether they are having same mean or if the mean is different, so which one is higher and which one is lower. And it can also be used for comparing standard deviation also. Further, this shape can also be used to examine whether the data is symmetrical. If data is symmetrical, then these values, these two boxes are of equal size and these two whiskers are of equal size, right? That is being used for the normality examination, as well as whether the data is having some skewness or cornices. So this is an important diagram. That's why we have discussed that much. Okay. So now I'm going back to our data sheet. And here I am discussing the another diagram that is box plot. So we go to graph, then we go to chart builder. Okay. And here we will be selecting this box plot. So we will be repeating that on the same example where we are comparing the total marks with respect to the sections as well as with respect to the gender also. So we require these cluster box plot. If if that is we don't require that much of comparison, means we simply want the position with respect to the different sections like this, right? So if we do this, okay, then we have something or the total on the y-axis, right? This is total on the y-axis and the sections on the x-axis. Okay, right? So it gives us the box with respect to the sections only. Now, I am not discussing this in detail because I am also introducing the cluster bar diagram and then we will be discussing that diagram only. So again, we are repeating that. We go to the graph, then to the chart builder. And now we are selecting this and dragging it here. That is the cluster bar diagram. So here, the total would be on the y-axis and sections on the x-axis. Okay. And gender, like the earlier case, we put this on the clusters. Okay. So now we have the uh, three set of boxes, one for section 1, section 2, and section 3, right? And they are separately, they are clustered in the form of females and in the form of males, right? Now, suppose we want certain editing, right? As you see here, the boxes are too thin, right? So it would be better that you can broaden the box.
So, there's a small glitch in the meeting. We'll resume shortly.
Hello.
Yes, sir. Yes, sir.
Okay, I'm very sorry. There is some unknown error. Means I don't know. My power plug uh, suddenly got no power, so that's why I have to means the Wi-Fi got switched off. Right.
Not a problem, sir. No problem.
Allow me the screen sharing, please.
Yes. Yes. You have.
Yes. Okay. So since there is a sudden break, so I will be just repeating what we are discussing earlier, right? I was probably when I was introducing the objectives or the purposes that can be done through the box plot. So these are the four things that we are going to do. That is examining normality, finding outlier or extreme value, then comparing center value, then comparing standard deviation. We are going to do this. And after that, I have just introduced um, these box plot. So the first one is a simple box plot where we have plotted the total mean score with respect to the section, these different sections. So these are the first box plot, right? As you see here, the case number 55 in the section 1 and case number 46 in the section 3 is having much lower score as compared to the other student. So that's why they are in the form of outlier, they are in the form of circle. If they are in the form of stars, that would be the extreme value. That will be the furthermore deviation. Okay, that we'll be discussing later on. So these are the boxes as you see here. This represents the median line. So the section A is having the highest median score, followed by this section C and section 3 and the section 2. There is a not much difference between section 2 and section 3, but section 2 mean score is a bit lower as compared to the section 3. Sorry. So this is the small difference in between them. Right? This is the highest score. So after that, I have attempted this cluster bar diagram. And here I was trying to do some editing. So I'm just repeating that editing so that, right here, uh, the bar diagram is with respect to the section as well as with respect to the genders, right? So what we do, we highlight, we double click on this diagram so that is being highlighted. Now, since these bars are too thin and too close, so we want them to be a bit thicker as well as the somewhat close by. So how that can be done? We double click any of the bar uh, or the box, right? And then these are the properties that got open. So here we will be having one tab that is the bar option, right? So this is the bar option at that point. Here the width of the bar is very low, just at 25%. So we can increase them. Suppose we increase them up to 70, right? Right? We can increase them up to 70. So we will be having somewhat thicker bars. Okay. And the cluster means the difference is at present 85. We can decrease them up to 75. So now there won't be much of the gap. And if we apply this and if we close this, so now you can see that difference, right? So as you see here, these boxes got thickened and the gap or the difference between them got decreased. So now they look better as the cluster diagram. Is that okay? So this is the changing the thickness of these two. And we can change the scale values also so that the differences are highlighted in a better manner. And as we see, there is no presence of anything, any graph or the presence of outliers, right? Up to outliers or extreme value up to 40, right? So we are making that correction also. So we double click the diagram and as we have done earlier also, we double click the scale values. We go to the scale, right? and we put the minimum as 40, right? Now we are starting from 40. So from 40 to 125. Since the gap is somewhat big, so we are not changing the major increment from 20 to some other value. Or you can change that to something at like 15. But I suppose the 10 or 20 looks better. So we apply this and we close this. So now they are representing this in a better manner. And if we close this, right? So now this is a better diagram as you see, right? Now we can compare these values. Now, since here the values are being divided into the boys and girls or the male and female, so now they are better highlighted. So as you see here, outliers are there only in the first section, section 1 only. And these are the case number, that is 75 and 55. So 75 and 55 case numbers have relatively much lower score as compared to the other students, right? Here I am showing you case number 55 and case number 75, right? And remember where the total score is. This is the total. So I am just putting total close to here. So this is the thing. And here we are going for the case number 55. This is case number 55. Right? If we go to this and check the total, total is quite low, that is 51, a very low score. In the same way, the case number 75 here is also having a low score, low total of 66 only. So that's why in this diagram, they are like, as you see, this value is in between 40 to 60. So it would be around 50 and the exact value is 51. That is a case number 55. And case number 75 is having somewhat higher value as compared to 60. And it is in between, means at the quarter distance from 60 to 80. So it would be around 63, right? So this value is 63. And as you can check for the section A, girls are scoring slightly better than the boys. This is a comparison of the central tendency. We are comparing them with respect to the median line. In section 2, the boys and girls are scoring approximately same. As you see, both the median lines are at the same position. In section 3, girls are performing substantially better than the boys because the blue central line, blue median line is much higher as compared to this red central line, right? That is for the male, right? This is the comparison of central tendency. Now, if we compare the dispersion for the section 1, right, as you see here, the bar that for the boys is much wider as compared to the bar of this, and the total box plot is taking a higher size as compared to the for the girls. So there is uh, quite means higher variability in the boys, in the males as compared to girls in the section 1, right? Now, if we come to this part, if we compare them here, right? Here, girls are showing higher variability, girls are showing higher heterogeneity, and boys are showing low heterogeneity or low or higher homogeneity. Here, for the section 3, girls are having relatively low variability or high homogeneity, and boys are having higher amount of variability or uh, dispersiveness, right? As you see, the bars or the total bar plot is much longer as compared to this one, right? So in that manner, you can compare the center tendency as well as the dispersion, right? So this is for the box plot, right? So hopefully these box plot are clear to all of you. Shipra, just I wanted to know, should I continue or should I put that for the next week? Hello.
Yes, sir. I think, sir, we can schedule another lecture for the next
Okay.
week.
Okay, right. So,
And
so just to make a point means what we have done up to this they will. And what are remaining here, right? Now I am taking back to you, the initial part, means the graph and diagrams that we are discussing. So the basic diagram that we have discussed, they are the bar diagram, line chart, and the pie chart. That is primarily used for the visualization purpose. We have some additional diagrams also, like box plot, this we have discussed, where we have some other information also through that diagram. Similarly, we will be discussing these two also. You people must be familiar with histogram. This is a common diagram, but I will be introducing one more diagram that is very important and somewhat more, uh, uh, somewhat providing more information as compared to the histogram, that is stem and leaf. Then we have the scatter plot where we examine the relationship. After that, we will be examining the normality through this PP plot and QQ plot. Here, I will be constructing histogram and the scatter plot through chart builder that I have introduced, right? But for stem and leaf and PP plot and QQ plot, I am directly using the legacy dialogues or through the built-in method that is available in SPSS, right? So this will be done on the next week. And in the meanwhile, if you means on the next time, if you people have some problem, you can always post and you can ask. We can take that at any point of time. Okay. And I will be sharing um, all this material with the organizers so that you people will be having all these things.
Yes. So I think, thank you, sir, for today's session.
Thank you.
Yes, thank you so much.
And hadn't been that break, so probably we must have covered either the histogram or the scatter plot.
Yes, but I think this was also one enlightening and one important session, and we can always break sessions for more receptivity. So if there's any doubt in future, we can communicate directly with you, and we can take up doubt sessions further in future as per your availability, as we were talking at the beginning of this meeting. So thank you today. Thank you so much for your time, and Merry Christmas.
Okay, thank you. Thank you very